Yo guys, welcome back to another video. So in this one, we'll be looking at two types of matrices. The first one is the adjacency matrix, and the second one is the distance matrix. And we're going to understand the key differences between the two. Now, what is the adjacency matrix since we're dealing with that first right now? Well, an adjacency matrix describes the number of arcs joining the corresponding vertices. So what they really want you to do is to basically draw a table or matrix and tell you exactly how many arcs or edges are coming off each point. For example, there's exactly one point coming off A as it directs towards B. Now, how do we illustrate this? Well, all you want to do is draw a matrix. So what I would do, I'll draw like a little sort of table style and just label exactly what vertices we have. So we've got A, B, C, D, E, F. So you want to put them all over here. A, B, C, D, E, and F. And then you want to do it downwards as well. A, B, C, D, E, F. And now all you want to do, and it helps to change color. Now all you want to do is literally just state exactly how many arcs are coming off each vertex. So let's go from A to B. So if we look at the column first as we go to the row, we've got A to B. We know there's exactly one coming off it, so you're going to put a 1 here. But then you realize from A it doesn't go to any other vertex, so we just leave it as 0 for the rest. Now if you look at B, if you go from B to E, you can realize there's two routes to go from B to E. So if we go from B and we place it over here, we put 2 here. Okay? So that tells you exactly from B to E. Now if you go from B to A, it goes exactly once. If you go from B to C, it goes once again. And if you go from B to F, it's also once. And the rest is 0. So 0, 0. Now, we just literally do this the same for everything. So that's literally all you want to do. Now, let's look at C as well. So C, it goes once to B. It also goes to E. And it also goes to D once. And that's it. So then you should put 0 for the rest. For D, it goes once to C and once to F. So once to C, once to F. For F is an interesting case. Look at it, it loops around itself. So that you can kind of think of it as two possible ways, either this way or that way. So actually, it goes twice. F goes to itself twice. So F to F. That's a special case. Now F to D goes once, and also goes to B and E, also to E. And now lastly, let's look at E. Yeah? So E goes to B twice, as we found out earlier. E also goes to C, and it also goes to F once. C once and F once. And that means the rest must be 0. It's always important to double check your results anyway, but this is basically a general idea, guys. If you see anything wrong with this, let me know, but that's how you do an adjacency matrix. Now, let's look at the distance matrix. So what is it actually? So a distance matrix describes the weight of each arc between two vertices. So it's completely different to the other matrix we just saw. Here we just care about the actual value of the arc itself. So in fact, this is not too bad. And how do we represent it? Well, we do the same thing. We draw a nice table. So let's just draw a nice table again. So once again, we're going to label this based on the number, based on the points. So we've got A, B, C, D, and E. So this is actually a lot shorter. So we just put A, B, C, D, E here, and also downwards, E. And all you guys want to do is basically look at the numbers and just say, okay, so between A to B is clearly 17. So put 17 over here. From A to C is 18. So this is just the distance or the weight of the arc. Now for the rest of them, if there's no more values, you don't put a 0. You could put 0, but we just put like a dash representing a blank, meaning it doesn't exist. There is no distance associated. You could say 0 actually, but we tend to use a dash. Now from B to A, we do the same thing. A point B, it goes 17 to A, 15 to C, and the rest on. So B goes 17 here. B to C is 15. And also we have B to E and B to D. So B to D is 19, and then 23 here. And that's it, and then you put a dash over there. And that's it, guys. That's literally how you do a distance and adjacency matrix. Hope this helps, and I'll see you guys in the next one.